Consider the following PDA transitions. Here PDA means push down automata. Transition 1, delta of Q0 A Z0 is Q0 X Z0. Delta of Q0 A X is Q0 X. Delta of Q0 BX is Q1 epsilon. Delta of Q1 B Z0 Q1 Z0. Delta of Q1 epsilon Z0 is Q1 epsilon. Here the set of states are Q0 comma Q1, and the set of inputs are A comma B, and the set of stack symbols tau is Z0 comma X. Delta is defined with the 5 transitions 1 to 5, and Q0 is initial state, Z0 is initial stack symbol, and F is equal to pi. That means the final state is pi. What is the, there is no final state, pi means. What is the language accepted by the above push down machine? Option A, L is equal to A power n B power n such that n starts with 1. Option B, L is equal to A power n B power m such that n comma m greater than or equal to 1. Option C, L is equal to A power n B power m such that n not equal to m. Option D, L is equal to A power n B power m such that n is equal to 2m. So here, if you observe these transitions, Q0 A Z0 means whenever the state is Q0, input A is encountered, when the top position is Z0, okay, then it is pushing X into the top of the stack. So now X is there in the top of the stack. If after A, if when top is X, if one more A is encountered, it is just going to the same state without pushing or popping. That means this X is as it is. A single X on the right side indicates that that is a bypass operation. Just any number of A's can be bypassed because it is going to the same state. For the first A only it is pushing X. For all the remaining A's, just it is bypassing. Now when B is encountered, when the state is Q0 and top is X, that is small b is encountered, it is going to Q1 and popping this X. Only one X is there, that is popped. Still we have Z0. So after 1B, if any number of B's are encountered, it is going to the same state and keeping Z0 as it is. And when epsilon means when the string is ended, it is going to Q1 and making the stack empty. Z0 is also popped. That means after, for example, if you take a string like this, for this first A, it is pushing X into the stack. For the second A, it is bypassing. Third A, bypassing. Any number of A's will bypass. For the first B, this X is popped. For the next B, this Z0 as it is. And for epsilon, this Z0 is popped. That means at least one A followed by any number of A's, followed by at least one B followed by any number of B's. One or more A's followed by one or more B's. That is A star, B star. Or else in the language format, it can be A power n, B power m such that n comma m greater than or equal to 1. Here n may be equal to m, n may not be equal to m. So option B is the right option. It accepts A power n, B power m such that n comma m greater than or equal to 1. That is A star, B star. So option B is the right option here. The following string of characters 5, 4, 3, 2, 5, 6, 7, 8, 9, 3, 2, 4, 1, 2, 3. In a data link layer, character count method is used for framing. Then the above message can be divided into how many frames? So the message contains the characters like 5, 4, 3, 2, 5, 6, 7, 8, 9, 3, 2, 4, 1, 2, 3. In a character count method of framing, we used to combine the characters as one frame just by adding the header of the count as the first letter. That is, here 5 is the header count. So there are 5 characters including this header. So 1, 2, 3, 4, 5. So these 5 characters is one frame. Let it be frame 1. Next is the start of the next frame. So 6 is the header. Count is a 6. There are 6 characters including this count. 1, 2, 3, 4, 5, 6. So this is another frame. So it will define the frame boundaries. Again, 4 is the head count. There are 4 characters. 4, 1, 2, 3. This is the third frame. So this total message using character count method can be divided into 3 frames. So option C is the right option here. First has the following IP configuration. So IP address is 195.65.2.125 and the mask is 255.255.255.0. It is given in the dotted decimal notation. Default gateway is 195.65.2.1 and DNS server 1. DNS means here domain name system. 195.65.2.200, and DNS server 2 is 200.120.190.14. And then suppose host want to log into IP address 205.75.33.4. Which of the following scenario is /r possible with respect to ARP? So as far as ARP is concerned, that is address resolution protocol, which scenario is possible? That's what the question is. Actually, the host IP configuration is given, and host want to log into the IP address 205.75.33.4 usually. So whenever if any host want to log into a particular IP address, we have to take the help of a DNS server, because the DNS server is responsible for getting the IP address of a given character oriented address. So that is why the ARP query, first of all, it will go to the nearest network that is in the same network, that is IP address 195.65.2.125. This is the host which want to log in into this address, that is 205.75.33.4. Here DNS server 1 is in the same network, that is 195.65.2, because it is a classy address. If you use the mask 255.255.255.0, the network address will become 195.65.2.0. That means the given IP address and the default gateway both are in the same network. In addition to the default gateway, the DNS server 1 is also in the same network, and DNS server 2 is in a different network. That is why ARP query is always going to the hosts within the same network. So that is why it will go to the query that is for default gateway, and that is for the DNS server 1. So ARP query is for 195.65.2.1, and also for DNS server 1 it is 195.65.2.200. Both A and C are possible, but B is not possible, because ARP query will not go to the different network. Within the network only it will go. So that option D is the right option. Both A and C are possible.
Here in this question, 3 statements about LALR1 parsers are given, and we need to identify the correct statement. The given first statement is LALR1 parsers have same number of states as SLR1 parsers. Yes, this is correct. The number of states in LALR1 and SLR1 parsers are same. So S1 is correct. Statement 2 is given as LALR derived from LR with no shift reduce conflict will also have no shift reduce conflicts. If there are no shift reduce conflicts in LR parser, and if LALR is derived from LR parsers, then there will not be any shift reduce conflict. So we can say S2 is also correct. Statement 3, LALR may create reduce conflict not in LR from which LALR is derived. So your third statement is also true. So here all the given 3 statements LALR1 parsers are correct. So we can say option D is the correct option.